Hi, and welcome back. This is Mr. Wakefield here, looking at sections 4.1 and 4.2 again together as a group. We already did one video on these two sections, and so this is going to be the second shorter video. We just have 6 more problems to do, but let's jump right into it here. If you go into the back into the second page of these pair of sections, 4.1 and 4.2, you have 6 problems back here that you see on the screen right now. And the first 2 problems ask for this thing called the X-Intercept and the Y-Intercept. Okay, that's actually something that we've already done before in the previous problems in these 2 sections. We just haven't worded it that way yet. Okay, as you know from the previous 4 problems, okay, right above problems E and F here, which we'll look at those answers, of course, here in just a moment. But for problems 1 through 4 up here, notice that in problems 1 through 3 in particular, I plugged in x equal to 0 and y equal to 0. Okay, same thing in number 2 and same thing in number 3. We did number 4 a little bit differently, but focusing on problems 1, 2, and 3, plugging in x equal to 0 and y equal to 0, I want you to notice something about all 3 of those problems that those 3 problems have in common. Okay, notice that when I plugged in x equal to 0 in all 3 of the first 3 problems here, okay, those 3 points, 0, 2, 0, -3, and 0, -2, they all have this one very significant thing in common, and that is the fact that they all are right on top of the y-axis. Okay, in other words, all 3 of those points are the points where the graph, the line in particular, crosses right through the y-axis. Okay, since it crosses right through the y-axis at those 3 points, 0, 2, 0, -3, and 0, -2, they call that the Y-intercept because it intercepts the y-axis or crosses through it, okay? And so the Y-intercept, therefore, is always the point that you get when you plug in x equal to 0, okay? So when they ask for the Y-intercept, all we got to do then is plug in x equal to 0, and then we then figure out what y value pairs up with it. Okay, now to figure out the x-intercept is very similar. Let's take a look at that from the previous problems here. Notice that 5, 0, when I plugged in y equal to 0, I got 5, 0 on this problem. When I plugged in y equal to 0 here, I got 2, 0. And then on this problem, I got 4, 0 when I plugged in y equal to 0. What do all 3 of those points have in common? Let's take a look at those 3 points. Those 3 points are this one here, and this one right here. What do they all have in common? They all cross over the x-axis instead of the y-axis this time. Okay, and so therefore we call that the x-intercept. All right, so let's review here. All right, for the x-intercept, that's when y is equal to 0. And for the y-intercept, that's when x is equal to 0. Okay, and so when you solve for the other variable, all right, to figure out what goes with the 0, that tells you what the x-intercept and the y-intercept are. Okay, so we're still going to do the same thing that we did in the previous 3 problems up here, okay, where we plug in x equal to 0 and y equal to 0 on these. It's just that now we actually have a name for those things, and it's the x-intercept and the y-intercept. So still going to do the same thing I did in problems 1 through 3 above. All right. We just got to be careful that we know which one's the x-intercept and which one's the y-intercept. Okay. I'll review that again here in just a moment. So for x equal to 0, as we talked about in the previous video for those previous problems, when you plug a 0 into a term, and here's the 2 terms right here on the left side of the equal sign, and then we have 1 term on the other side of the equal sign. So as we said, if you plug in a 0 into a term of a polynomial, and this is a 2-term polynomial here on the left of the equal sign, it basically makes that term disappear. So the -5x just disappears, and you just end up with -2y equal to 10. You then solve that equation, and as we talked about many times in the previous video, when you have a single term on each side, with the variable only on one side, you then can divide out by the coefficient of that variable, and we get y equal to negative 5. So that means that 0 pairs up with negative 5. Okay, what about when I plug in y equal to 0? A very similar thing happens, right? Okay, this time it's the y term that disappears because we plugged 0 into y. Okay, so the negative 2y term disappears because negative 2 times 0 is 0. All right, and since this is negative 5x plus negative 2 times whatever you plugged in, it's like adding 0. And you know that when you add 0, you don't need to write that. Negative 5x plus 0 is just negative 5x only. All right, so you don't need to add or subtract 0 to something. Okay, it's not going to change it. So you don't need to write plus 0 or a minus 0. Okay, it's not going to change anything. Now, once again, we have a single term on each side with a variable only on one side. And so that makes it, you know what, I probably shouldn't go over here because that's going over to the next problem. I need room for that. So let me just move that over to the other side here. There we go. But I need to do what here on this last step? I need to divide out, right? And I get x is equal to negative 2. So that means that y equal to 0 pairs up with x equal to negative 2. Okay. You don't need to graph this problem. However, if it helps you figure out, let's say you're on a test question, for example, and you're trying to remember, oh, which one of these is the x-intercept and which one of them is the y-intercept. You could go ahead and graph this. Remember, you only need 2 points to graph a line. So you could graph this problem. It doesn't ask you to graph it. So again, this is completely optional. But if it helps you realize which one is which here, because you got to tell me which one's the x-intercept and which one's the y-intercept, then go ahead and do that. Okay, but remember, as we saw earlier, if you remember this and you're sure you remember it, then you don't need to graph it. Okay, but the x-intercept is whenever the y is 0, and the y-intercept is whenever x is equal to 0. So because of that, the negative 2 comma 0, that is the x-intercept. Okay, and if you graphed it, just to confirm this with you now, if you graph this point right here, that would be the point that's right on the x-axis. Okay, therefore, when you draw the line, if you were to graph it, that would be the point right there where the line would cross through or intercept the x-axis, and thus it's called the x-intercept. So then the other point here is the y-intercept. Whenever x is equal to 0, that's the y-intercept, and therefore that's why I put 0 comma negative 5 with the y-intercept. Okay, let's do that one more time here. Again, we want to do x equal to 0 and y equal to 0. Okay. Starting out with x equal to 0, we get y equal to 4 times 0 minus 1. And as I mentioned in previous problems on the previous video, we want to realize that if you plug a number into one of the variables and the other variable is already by itself, assuming that it's by itself and it's not on this side, okay, that's the opposite side of where it's by itself, okay, then all you got to do is just do order of operations right here, because the y is already by itself. You don't need to move terms around or do that division step that we've been doing, okay? You just need to figure out what this side's equal to. So assuming there's no variable over there to get in the way, you can do order of operations to just figure out what y is equal to. Multiplication comes first. 4 times 0 is 0, and then 0 minus 1 is negative 1. So that means that x equal to 0 pairs up with y equal to negative 1. Okay, now I need to plug in x equal to 0. Okay, and let's go ahead and do that. I'm sorry, y equal to 0. I already plugged in x equal to 0. I need to plug in y equal to 0. Y equal to 0. Again, you don't need the parenthesis if the parenthesis is the only thing on that side of the equal sign. I put it there just out of the habit of we always use a parenthesis when we plug a number into a variable, as we mentioned in the last video. and as we did over here on these problems when I plugged in the zeros. Okay, so you could get rid of the 0 there, but what do I got to do here with 4x minus 1? Okay, how do I get x by itself? Because remember, when you plug into y, you then got to solve for x. All right, well, that's something that we talked about briefly in our previous video. Okay, let me review that with you. Okay, notice here after, first thing you want to do is figure out what the term is equal to that you plugged into. That's always true. Okay, but it's just equal to 0 there. Okay, I plugged into the y, it's equal to 0. There was nothing to multiply by it. Okay, outside the parenthesis like there is here with the negative 2 times 0. Okay, so we got 0 equal to 4x minus 1. We figured out what the term was equal to that we plugged into. Then we solved the equation as normal. But we still have 3 terms here. Unlike these other problems here where when you plugged in the 0 and one of the terms disappeared, oftentimes you ended up, actually it's more like over here, and one of the terms disappeared, you ended up with just 2 terms left. That doesn't happen here, okay? You still got 3 terms. This is similar when you got 3 terms, 1 on one side of the equal sign and 2 on the other. This is similar to this problem that we did, problem C on the first page from the last video, where you got 2x plus 7 equal to 14 after you figured out what the term was equal to that you plugged into. 2x plus 7 equal to 14. And what I mentioned to you guys, which you're going to see a lot more of later, but right now we need to know what to do, is that if you have 3 terms total, 2 on one side and 1 on the other, and one of them has the variable in it and the other 2 don't, what you need to do is you need to move the 2 terms that don't have the variable in it to the same side if they're not already. So I had to move the 7 over to 14, and I had to do that by adding the opposite amount. So if this had been minus 7, you would then say plus 7 underneath that. But because it was plus 7, we said minus 7. Okay. So whatever the sign of that is for that term, you got to do the opposite thing. If it's positive, you got to subtract. If it was negative 7, you'd have to add. And so same idea here, because of the fact that we need to move the 2 terms that don't have the variable in it, okay, to the opposite side of where the x is. That's the idea, just like we did here. We wanted to get the 7 and the 14 on the opposite side of where the x term was. Same thing here. We want to get the 0 and the negative 1 on the opposite side of where the x term is. That means I need to move the negative 1 over with the 0. But because it's negative 1, I need to what? I need to add 1. Because then when you combine like terms on these 3 terms right here, including the plus 1 on the bottom there, the negative 1 and the 1 cancel each other out, and we're left with what? We're left with 4x on the right-hand side of the equal sign. Okay? But then, and I'll go ahead and zoom in here a little bit more, but then on the other side, we have 0 plus 1 equal to 1. So that's what you got to do when you got 3 terms, no parentheses or anything like that, just 3 terms, 2 on one side and 1 on the other, and the terms that don't have the variable in it are not on the same side. You need to move them to the same side, but it has to be the opposite side of where the variable is. Because remember, we want to end up with this situation where you've got 2 terms, 1 on each side, but the variable is only on one side, okay, not on the other. And so by moving the 0 and the negative 1 to the same side, that happens. All right. So you need to get the terms that don't have the variable in it on the opposite side of where the variable is. That's the ultimate idea there. Then you do this division step, okay, that we've been doing. Got to divide by the coefficient of the variable term to get the x completely by itself there, okay, and that gives me x equal to 1/4. You don't need to make that into a decimal this time because we're not graphing it. Okay, if you do decide to graph it just to get a visual of what the intercepts are, then you can put that in your calculator, but otherwise you don't need to. It's okay to make it into a fraction if you don't need to graph it. So 1/4 comma 0 for that. Which one is which though? Which one's the x-intercept and which one's the y-intercept? Again, as it says up here, when x is equal to 0, that's the y-intercept. So therefore, 0 comma negative 1 is the y-intercept, And when the y is equal to 0, that's the x-intercept. And so we get what? We get 1/4, comma, 0. Okay. So there are your answers there for those problems. That's what we had to find. Okay. The x-intercept and y-intercept. That's all they asked for. Again, no graphing is required there. Okay. And that brings us to the last 4 problems here. What is unusual about these 4 equations down here, problems 5 through 8, compared to the equations that we graphed in the first video, you guys? Okay. What's unusual about them is that they only have one variable in them, right? Okay. Whereas the graphs that we did before, they had 2 variables. 2 variables there, 2 variables there. We had 2 variables in the 4 problems that we did at the top of the second page. Okay. All of those have 2 variables. So whenever I've asked you to graph thus far anyway, it always had 2 variables. So why do these only have 1? And what do we do? Do we have to do something different? Yeah, we do need to do something different, but it's actually easier. You just need to remember what to do. It's a shorter problem. Okay, but I'm going to do it the long way first. And the reason for that is because it'll help you understand the shortcut better. Anytime you look at the long way to do something before you see the shortcut, it'll help you understand the shortcut better. So you don't need to write down this long way of doing it. Okay, you don't need to. Okay, you can just watch me do this, and then when I show you the shortcut, I'll put it down on the actual worksheet page, and then you go ahead and write that down like normal. Okay, so because the y variable is missing here and only the x is there, what I'm going to do, just so that I can do the same things that I've been doing on the other graphing problems, which had 2 variables in it, is I'm going to actually put the y in here. Now, am I allowed to do that if it's not there? Yes, but you got to do it a certain way. Okay, you can't just put the y in there. You can't just say xy or x plus y, or you can't just throw it in there any way you want. You got to obey mathematical rules and all that kind of stuff. So here's what you want to do. Again, this is a long way of doing it. You don't need to do it this way eventually, but this will help you understand the shortcut. What you do is you realize that x is the same thing as x plus 0. So I'm going to put a plus 0 next to the x right there before the equal sign. So basically what I did there was I squeezed in a plus 0 in between the x and the equal sign. Otherwise, it's the same equation here. So are these 2 equations equivalent to each other? They are, because anytime you add 0 to something, it's still the same thing, isn't it? 5 plus 0 is 5. 7 plus 0 is still 7. X plus 0 is still the same thing as x. So this is still the same thing. Okay. Now the reason why I did that is because we know that 0, you guys, is the same thing as 0, and let me give myself some room here. 0 is the same thing as 0 times y. Because 0 times anything is still 0, isn't it? Right? And so, yeah, and in fact, let me write down that previous thing that I had written here just so you can see it all together. So x is the same thing as x plus 0. We agree with that. Okay. Then we also realize that 0 is the same thing as 0 times y. So we can now see that x plus 0y equal to 2 is still the same equation as this. It just looks a little different, but it's still equivalent. Okay, because 0 times y is 0. And when you add 0 to something, it's still the same thing as just the x only. Okay. Now, why would I do all this? It's because now I have 2 variables. So that means I could still do that same thing that I always do, okay, where I plug in numbers and stuff. But there's one thing we need to do a little bit differently here. Okay, when you have a variable being multiplied by 0, do not plug into the other variable. You have to plug into the variable that's being multiplied by 0. The reason why is because if I plugged into x, then I would have to solve for y, right? Whatever variable you plug into, you got to solve for the other one by getting the variable by itself. In order to do that, I would eventually have to divide by the 0 there. Okay, just like if I had 2y, I would have to divide by 2 eventually to get the y by itself. We've seen that in previous problems here. Like right here, I had negative 2y, so I had to divide by negative 2 eventually to get the y by itself. Here I'd have to divide by 0. Well, you're not allowed to divide by 0. Okay, and I'll talk about that more in the next section if you don't remember why. But whenever you divide something by 0, there's no answer. And again, I'll go over that more in the next section. It'll make better sense at that time. But dividing by 0 doesn't work, and so we only want to plug in numbers into y. So let me just pick a couple of numbers. Remember, you can pick anything you want when you have a 2-variable equation. Okay, if you have just a 1-variable equation, you can still pick anything you want, but you have to plug in to the variable that's being multiplied by 0 if you do it the long way. Okay, and the shortcut, you're not even going to need to plug in any numbers at all, so don't worry about that. But if you do it the long way and you have 2 variables in here, okay, you can only plug into the y, but you can still pick anything you want. Okay. So if a variable is missing and you do it the long way, that means you put the plus 0 times that missing variable there, okay, and then you plug in only into that variable. We'll see something similar for the next problem, only that in that case it's going to be 0x because the x is missing. Anyway, back to this problem. If I plug into that, what happens? If I plug the 0 in there, again, what happens? No matter what I plug in, it's going to get multiplied by 0. And anytime you multiply by 0, it's equal to 0. And we know that when you add 0 to something, the plus 0 just disappears, doesn't it? We've seen that before. Okay? And so my point is that it doesn't matter what you plug in. You could plug in 1 into the y. Okay? You're still going to get x plus 0, aren't you? Because no matter what number you plug in here, it's going to get multiplied by 0, and it's always going to be equal to plus 0 every single time. And the plus 0, again, can be gotten rid of. You can get rid of it because, like I said, plus 0 doesn't change anything. And so you're always going to end up with x equal to 2. That's the thing I want you to realize here, you guys, is that when a variable is missing, and in this case the y is missing, that means that if you do it the long way, you're going to get 0y, and that means that no matter what you plug into that, the x will always be the same. If I plug in 583 into the y right here, it's still going to be x equal to 2, isn't it, as our answer? Because the 583 is going to get multiplied by 0, and you're still going to end up with plus 0 no matter what number you plug in, no matter how big it is. Okay? And so that's the lesson here. Okay? That's the long way of doing it. The shortcut is to realize that since, I'll write this down, since the y is missing, okay, the x will always be the same. All right. And if you forget to write down these words, I'm not going to mark you down as long as your graph is correct. But I want you to write these down for now so that you'll understand where you got your answer from when you study. Okay, so since the y is missing, x will always be the same. And so whatever x is equal to, okay, that's what you're going to get. So the long way of graphing it would be to plot these 2 points. 2, 0 is right here. 2, 1 is right there above it. And that's a special kind of line that we haven't seen before. That is a vertical line, meaning it's straight up and down. It doesn't go to the right at all. It doesn't go to the left at all. And as it turns out, you guys, every single equation that has y missing is going to be a vertical line. Every single time, without exception. Because when what? When the y is missing, x will always be the same. And this always leads to what? This always, I'll put that in caps here to make it clear that's always true. This always is a vertical line, meaning it goes straight up and down like this. Okay, so if the y is missing, you always get a vertical line. Okay, the shortcut is to see what x is equal to, and you don't have to plot the 2 points. You don't have to do any of this stuff when you do the shortcut. Okay, the shortcut is just to look at this, realize that the y is missing. That automatically means it's a vertical line. The second you look at it, you should say to yourself, oh, y is missing, it's a vertical line, if you're doing the shortcut. And then you just have to look at what x is equal to, go to the x-axis, where x is equal to 2, go to the x-axis where x is equal to 2, and then just draw a vertical line through that. Okay? So you don't need 2 points if it's a horizontal or vertical line. You just got to realize where it starts at. And if x is equal to something and there's no y there, you just go to that spot on the x-axis and you draw a vertical line through that. Okay. Same thing happens here, only now it's the x that's missing. Are we going to get a vertical line again? No, we're not. Okay, because when the x is missing, it just creates a different situation. It's got some similarities, but just like I just said here, if I want to put the x in here, I add a 0. It doesn't matter if you put it on the left-hand side of the y or on the right-hand side of it. Okay, I'm adding a 0, and that's still the same equation as this. Okay, so again, this is the long way. You don't have to write down the stuff here on this piece of scratch paper. The long way of doing it is to realize that the y is the only thing that's there. The x is not there. So as you guys know, when I add 0, it's still the same equation. But if I say 0 times x, that's still the same thing also, because 0 times x is the same thing as 0. And 0 plus something is still the same thing as not having the 0 plus there. So ultimately, this equation right here, the second one, is the same thing as this. But the reason why I wrote this is because now I have two variables, which means that I can do, as the long way of doing the problem, if you choose to do so, I can do the thing where I plug in numbers, because that's what you do when you have two variables. So remember now, when you plug into the term where it's being multiplied by 0, okay, that's the only way that you can do it when you have a variable that's missing and you put that 0 term in there. You have to plug into that one, because like I said, if you plug into the y, you would then have to solve for x by dividing by 0, and we can't do that. So when you have a 0 term with the 0 times the variable, you got to plug into the other variable. You have to plug in only into that variable that is being multiplied by 0. You can't plug into this one, because if you did, you then have to divide by 0. So, and that's only if you do it the long way. If you do the shortcut, you don't even need to plug in anything at all. Okay, it's just when we do the equations that have both of the variables in it that you plug in the numbers into one of the variables, and then you solve for the other variable, just like we've been doing throughout these two sections, 4.1 and 4.2. Okay, but if you do the shortcut where you don't put the second variable in there, we don't even need to plug in any numbers. Okay, as I talked about that in number 5, and you'll see that again here when I show you the shortcut for number 6. Okay, so this is completely optional. That's why I'm doing it on a piece of scratch paper. So I'm going to plug numbers into x. I'll just pick the same two numbers I did last time, 0 and 1. And again, you can see here that if I do that, no matter what I plug in, it could be 0 and 1, it could be 5 and 7, it could be 123. It doesn't matter. No matter what you plug into the x right here, it's going to get multiplied by 0, which is going to make it equal to 0. Remember, you figure out what the term is equal to first after you plug the number into the term. And then what we have is 0 plus something. Okay, you have 0 plus something, and you can just get rid of the 0 plus, just like I got rid of the plus 0 over here. If you have 0 plus something, or if you have plus 0 behind something, the plus 0 and the 0 plus, they can be erased. They can be gotten rid of. It doesn't change anything. 0 plus 7 is still just 7. In the same way, 0 plus y plus 1 is just y plus 1. Okay? And so no matter what, you guys, what's going to end up happening, we still got to get y by itself. All right? And remember, if you've got, here we go again here with these three terms. We saw this earlier. If you got three terms, one of them's got a variable in it and the other two don't, okay, you have to what? You have to move the two terms that don't have the variable in it to the opposite side of where the variable is. And since this is plus 1, I'm going to subtract the 1. The 1's cancel over here in the middle. And then that gets y by itself. And then you got 0 minus 1 is negative 1. You don't need to divide out, okay, because the y's already by itself. It's not 2y or 3y. It's just y. And so the point is, you guys, is that no matter what number you plug in, you're always going to end up with y plus 1 equal to 0, which is the original equation, by the way, right? Okay. And so you just have to solve for y, and then the y's will always be that same thing because you're always going to get that same result, y plus 1 equal to 0. And so you're always going to end up with y equal to negative 1 no matter what number you plug into the x right here. So here's the lesson. Here's the shortcut. The shortcut is this. It's very similar to the last problem. It's just the variables are playing the opposite role here. Since the x is missing this time, okay, since the x is missing, y now will always be the same. And again, you don't have to write this down when you do like a test question or something. You just have to graph it. But this will help you with your studying to make sure you understand why this graph is different than the graph in number 5, and it will be. And you'll see why here in a minute. Okay, y will always be the same, and this always is what? It's not a vertical line this time. It always is what? Is a, and before I answer that question, let's go ahead and plot these 2 points down here. Again, you don't have to normally do that if you're doing the shortcut, but let me just do it this time so you can see how this all works out. There's 0, negative 1 right here. Here's negative, pardon me, I'm on the wrong side there. 1, negative 1 is over here, excuse me. Okay, let me get rid of that. Okay. And so if I draw a line through that, that's not a vertical line. That is a line that's straight across, isn't it? It doesn't go up or down at all. It's straight across, and we call that a what? We call that a, I'm just going to try to draw it here without the thing. It's hard to draw that there. It is a horizontal line. Horizontal line. Horizontal line is a line that goes straight across. It doesn't go up or down at all. Okay. Vertical lines go straight up and down. They don't go right or left at all. They just go straight up and down. Okay, so this is always going to be a horizontal line. So if the x is missing, it's always horizontal. Okay, the shortcut would be to do what? If you don't want to do all of this, that's fine. The shortcut is to look at this and say, hey, the x is missing. It must be a horizontal line because it always will be when the x is missing. Okay? And so, and that it always happens that when the y is always the same, it's going to be horizontal. Because if you look at every single point on this line right here, the y's, no matter what point you look at here, the y coordinate, the y portion of each point is going to be always equal to that same number, negative 1. Just like on this line here, if you look at any point on this vertical line, the x's are always going to be 2. Okay, no matter what point you highlight there, even if it's way up here, the x is still equal to 2. So the x's are always the same with vertical, y's are always the same with horizontal. But anyway, the shortcut is to look at this, you realize the x is missing, you realize it's a horizontal line, so what you got to do is, since the y is not by itself, you got to get it by itself. You do the same thing that I showed you here, where you have to move over the 1 with the 0 to get the y term by itself. And then since y is already by itself, you don't have to do that division step that we normally do. Okay, but the important thing is you get y by itself. Don't say that y is equal to 1 here. It's not. Okay, you got to get y by itself so that you know what it's equal to. So the shortcut is to do that same step here. You don't have to do any of the plugging in stuff. That's when you have 2 variables. Okay. The shortcut is to just get the y by itself like you normally would, like I just showed you by moving over the 1. And then once the y is by itself, you say to yourself, oh, hey, y is equal to negative 1. Dan, just like we did here with the x, and we found the 2 on the x-axis because the x was equal to 2. Since the y now is equal to negative 1, we go to the y-axis and we go down to negative 1, not on the x-axis, but on the y-axis, and we draw the horizontal line through that. Okay? So on both of these problems, get the variable by itself if it's not already, and then you just need to know if it's vertical or horizontal. If you know that and you're sure about it, you don't need to worry about doing it the long way. Okay, just go to that spot on the appropriate axis Here would be the x-axis, here would be the y-axis, and then draw the appropriate line through that. You don't need the 2 points. Again, that's optional if you want to do it the long way. So you can see here in problems 7 and 8, a similar thing happens. Okay, x is missing here, y is missing here, and so based on the words that I wrote down in the previous 2 problems, you know exactly what kind of line you have. You just need to get the x by itself right here, doing the same thing I did with this one. Get the x by itself here so you know what x is equal to. You got to know what the variable is equal to so that you know where to go on the x-axis to find where to draw the appropriate line. Okay, so go ahead and try that. All right. Hit the play button after that, and we'll take a look at those last 2 answers. Okay, so let's wrap things up here. Number 7, since x is missing, y will always be the same, just like I mentioned up here in number 6. Okay, and this always is a what? Well, when the x is missing, it's always going to be, as it says up here in number 6, it's always going to be a horizontal line. So 7 and 6 are similar. The one difference is that the y is by itself this time. Over here it wasn't. Okay, so since it's already by itself, I know what it's equal to. And so I just have to go not to the x-axis, but to the y-axis because it's y that's equal to 2, not x. So I go to the y-axis where y is equal to 2 on that axis. And since it's a horizontal line, I just draw a line that goes straight across. Don't forget your arrows like always with our lines. Okay. Draw a horizontal line through that, straight flat across, and that's all you got to do. You don't need 2 points if you're doing the shortcut. Okay. Finally, in number 8, since the y is missing, similar to this problem up here where the y was missing, it is always going to be a what? It's always going to be a vertical line. Let's write that down if you haven't done that already. Vertical line. Okay. But I don't know what x is equal to yet because it's not by itself. So I need to take x plus 5 equal to 0. And again, we have the 3 terms again. We have the 2 terms that don't have the variable in it, plus 5 and 0. And then I have the term that does have the variable in it. So I need to move the 5 and the 0 so that they're on the opposite side of the equal sign from where the variable term is. Okay. And so since this is plus 5, I need to subtract 5, okay? That makes the 5 and the minus 5 cancel if you were combining like terms, which is what we need to do here. I combine like terms over here as well, and I get negative 5. But on the left side, since the 5's cancel, I just get x. Bring down the equal sign, okay? And so that means that x is not 5, it's negative 5. We got x by itself so that we know what x is equal to. It's equal to negative 5. And since it's x and not y that's equal to negative 5, we need to go over to the x-axis, not the y-axis, to where x is equal to negative 5 on that x-axis. Then we draw the appropriate line. What's the appropriate line again? It's vertical. Okay. So we go straight up and down. Okay. So if you do it the long way, it'll tell you whether or not it's horizontal or vertical just by plotting the 2 points. You draw a line through it. It's either going to go straight up and down or it's going to go straight across. But if you do the shortcut, you just got to make sure that you remember which one is which. If x is missing, it's horizontal. If y is missing, it's vertical. Make sure not to get that mixed up. Okay, make sure you know that. So when you have an equation with only one variable in it, you guys, that's the one where if you do the shortcut and not the long way, you do it like we did here. But if it has 2 variables in it, for example, if you put a second variable in this and do it the long way, or if you do any of those other problems that we did from the first video from these 2 sections where it already has 2 variables in it, that's when you do the thing where you plug in a couple numbers, you get a couple of points, you then put them on the graph and draw your line through that. Okay, that's the difference there. 2 variables, that's what you do. If both of the variables are visible in the original problem, that's what you do. Now, there will be a different method that we'll see in the next section or two besides this one that you're going to do when you have both variables in the original problem, okay? But that'll just be another method. Okay, this method is still something that we need to make sure we know. It's just that we'll have a second method that we can use in some cases as well. Okay, so we're going to learn two different methods for graphing an equation that has both of the variables in the original problem here, as opposed to one of them missing. Okay. But when we have the problems where one of the variables is missing, it is okay with me if you just do the shortcut every time. Okay, like we did here. This is better than what I have here. This is an old sheet here. This is better right here. If you do the same thing we did here when one of the variables is missing from the equation, you'll be fine. Okay. So that concludes 4.1 and 4.2. We'll see you back for section 4.3. Okay. Again, let me know if you have any questions about this. Since this is the beginning of the chapter, you want to really let me know if you have any questions because we're going to really need to know a lot of these concepts here moving forward as we go throughout chapter 4. Okay, so have a good day. You take care, and we'll see you back for section 4.3.